So we have the 0.37, we go over 2, up 5, and that's the instruction, okay? Then we get to 0.512 very clearly, and it's very straightforward, and that, just do that mentally, because we certainly shouldn't need a calculator to do any of that. Okay, so we get our slope, rise over run, 5/2. That's how it's labeled, right? And then the hypotenuse, square 2, square 5, add them up, you get 29, it's the square root of 29. Okay? Then what do? We go to the right 5, so we're going to go 5 units here. I'll kind of use the same kind of color coding I did before. So we go over 5 units and down 2, and we get this triangle, right? And if we just focus on green, we see exactly what we have. We have a slope of -5/2, and we have a hypotenuse, coincidentally, to square root of 29, because of course I gave you a rise and run that have the same magnitude as the rise and run before. I just switched them around and made one of them negative, right?
Wouldn't it be -2 over 5?
I wish y'all would stop making mistakes. Yes, it's -2 over 5. That's what you get when you try to do it too fast. Okay.
Perfect shape.
Thank you. So it's -2/5. We would have caught that later when we ask ourselves, is this the negative reciprocal of this? And just a little foreshadowing, yeah, it is. Okay? Now, we have a third fundamental triangle between labeled points, okay? Of course, I haven't labeled this point, so maybe I'd better. This point is going to be 8/5, right? So now, we're going to do a fundamental triangle between these two labeled points. So I'm going to do it like this, okay? So, what's the rise?
Rise is 7.
Okay, if we do 12 minus 5, that means, of course, we're going in this direction, right? So second point minus the first, 7 is just fine. And then it's 8 minus 5, which is -3, right? Okay. Now, if you went from left to right, it would be 3 and -7, but there's, as long as you put an arrow on there to indicate what direction you're going, it doesn't matter. Okay? So, the hypotenuse is going to be what? Well, 7 squared is 49, 3 squared is 9, right? And 49 and 9, as I discovered in the last class, is 56, right?
58.
58. Okay. And the slope isn't going to be important. Okay? I could write the slope down. I'm not sure I asked you to write the slope down.
It just says.
If I did, you should. Okay? But there it is. Okay, so there are 3 fundamental triangles. We can figure them out in just a couple of minutes, right? Okay? Now we've got to be careful, when you go over here and down here, doesn't mean you go over here, then you go down here, right? You got to, start from where you ended, but I think everybody understands that. A couple of people made a mistake on that, no big deal. Be sure you understand. Now, this triangle here is the thing I want to focus on. Okay? What do I know about that triangle?
Is that a 4th triangle?
Okay? This blue triangle that connects the 3 points, what do I know about it? Do I know anything?
You got the two legs, square root of 29.
Yeah, I've got square root of 29 here, and I've got the square root of 29 here, and the square root of, 58 here. Right? I've also got a slope here, we might as well put that in. That 2/5, right?
Yeah, -2.
Well, I want to write down 5/2. Okay, and the slope of this one doesn't matter, okay? So if this is a right triangle, what should its hypotenuse be?
What would be 29? Square root of 29, square root plus square root of 7, square root.
Well, the hypotenuse is the sum of the squares of this side and this side, square root thereof, right?
Yep.
Okay? What's that give us? Well, what's
I
the
can see what you-
square of the square root of 29? Well, the square and the square root are inverse operations, just like the square root function and the x squared function are inverse functions, provided you restrict the domain of the x squared function. So that's going to give us 29 plus 29. And what's 29 plus 29?
58.
58, isn't it? So we have the square root of 58. Okay? So, if it's a right triangle, then the hypotenuse should be square root of 58. And that should be equal to the sum of the squares of the two legs, right? So this is a right triangle. Which means that this angle is a right angle, right? And of course, that's the angle you have up here between these two segments, right? And that means that these lines that you get through these pairs of points, and most importantly, the lines with these two slopes are perpendicular, right? So our conclusion is okay? Now, this doesn't prove that negative reciprocal slopes make lines perpendicular, because this is only an example for one specific rise and one specific run, right? So it's only for slopes of 5/2 and negative 2/5. But if you do it in symbols, you get a proof that perpendicular lines have negative reciprocal slopes. Now we understand what I mean by negative reciprocal, right? You know, the reciprocal of 5/2 is 2/5, right? And the negative of that, well, that's what we have, right?
Yeah.
Okay.
That's a perpendicular sign right there. Relevant to prove that.
Yeah, well,
Perpendicular lines have-
we proved that this triangle is a
That's
right.
what you wrote.
Okay, what would I say? This develops, our example here develops into proof that perpendicular lines have negative reciprocal slopes, if you use symbols. Okay? If instead of 2 and 5, you did this with legs A and B, and then a leg of B and negative A, and worked out the symbols, which wouldn't be difficult to do, and actually I kind of ask you to do that, okay? Then what you have ends up with a proof, and it's a little stronger than what I said. The lines are perpendicular if and only if the slopes are negative reciprocals. Now, we're just going to learn to use that, but this is why it is. And this is an important picture for understanding the analytic geometry of lines in the plane. Okay? So if I was to ask you to do this, I would expect you to be able to do it. Okay? If I was to ask you to do the general proof, well, that would be like an extra credit problem. I wouldn't expect you to do that in the course at this level, but it's something that, you know, if you understand this, it's not hard to understand that, and it's worth understanding. Okay?